Welcome to the DIY Honda Garage channel. This presentation focuses on troubleshooting Diagnostic Trouble Codes, DTCs, P0351, P0352, P0353, and P0354, which pertain to ignition coil circuit malfunctions in the Honda Civic models from 2011 to 2015. Each code corresponds to a malfunction in the ignition coil circuit for cylinders number 1, number 2, number 3, and number 4, respectively. The ignition coil is a crucial component in the ignition system, transforming battery voltage into the high voltage necessary to ignite the fuel-air mixture in the engine cylinders. So when any of these codes are triggered, it can affect engine performance significantly, leading to issues such as misfires, decrease in power, increased emissions, and poor fuel economy. Understanding the roles of various components, like the ignition coils and engine control module, ECM, is essential in the troubleshooting process. The ECM controls the ignition system, monitoring various inputs and outputs to ensure optimal operation. In this guide, we will go through systematic troubleshooting steps, examining each possibility that could lead to these error codes, allowing for a thorough and effective repair plan. The ignition coils in the Honda Civic 2011 to 2015 are vital for the ignition process, as they convert low battery voltage into the high voltage needed for spark generation. There are 4 ignition coils in this vehicle model, 1 for each cylinder. Each ignition coil is located on top of its corresponding cylinder, making them accessible for inspection and diagnosis. The engine control module, ECM, oversees the operation of these coils, ensuring they are functioning properly. When a malfunction occurs, the ECM records the error by activating the DTCs. P0351 for cylinder number 1, P0325 for number 2, P0353 for number 3, and P0354 for number 4. Any one of these malfunctions indicates an issue with the corresponding ignition coil circuit, whether due to a faulty coil itself, wiring issues, or problems with related components such as relays and the ECM. Correct identification of the faulty component is key to resolving the issue and restoring optimal engine performance. Several potential causes can lead to the activation of DTCs P0351 through P0354. A faulty ignition coil is a primary suspect, as it may fail to deliver the necessary voltage to create a spark at its corresponding cylinder. This could be due to age, wear, or manufacturing defects. Shorted wires in the ignition coil circuit can also result in incorrect voltage readings, causing the ECM to flag a malfunction. Instances of bad connections, such as poor or corroded terminals at the ignition coils or the ECM, may lead to intermittent issues, making the vehicle difficult to diagnose. Additionally, a defective ignition coil relay can result in insufficient power being transmitted to the ignition coils. Finally, an issue with the ECM itself, whether due to outdated software or internal faults, can lead to inaccurate readings and miscommunication regarding the ignition system. Identifying and rectifying these causes is crucial in the troubleshooting process. When these DTCs appear, the driver may experience several noticeable symptoms reflecting the underlying problem in the ignition coil circuit. An engine misfire is one of the primary symptoms, as failure to ignite the fuel-air mixture in the affected cylinder disrupts the normal rhythm of engine operation. As a result, drivers may notice a decrease in power output, which can affect acceleration and overall performance. Increased emissions could also occur due to incomplete combustion, which may lead to greater environmental impact and potential passing issues during emissions testing. Drivers might encounter a rough idle, indicative of inconsistencies in cylinder firing, further detracting from a smooth driving experience. Poor fuel economy may arise due to inefficient engine performance, leading to increased fuel consumption. Understanding these symptoms is important, not only for prompt diagnosis, but also to alleviate further damage to the vehicle. The first step in troubleshooting these DTCs involves verifying the problem with a structured approach. Begin by turning the ignition switch to the on-to position, which powers the electrical systems of the vehicle without starting the engine. Next, use the Honda Diagnostic System, HDS, to clear any previously recorded DTCs, thereby resetting the system. After this, start the engine and again use the HDS to check for any pending or confirmed DTCs. This will help determine whether the issues are persistent. If DTCs P0351, P0352, P0353, or P0354 are displayed, it confirms the failure is duplicated and you can proceed to the next step. Conversely, if no DTC is present, it indicates an intermittent failure. Thus, you should inspect the ignition coil connections and the engine control module, ECM, for any loose or corroded terminals that could lead to these faults. In the second troubleshooting step, you need to further isolate the issue by testing the ignition coils directly. First, turn the ignition switch to the lock 0 position to ensure all electrical power is cut off for safety. Once powered down, carefully exchange the ignition coil from the cylinder that is exhibiting a malfunction with one from a different cylinder. After swapping the coils, restart the engine. Use the HDS once again to check for any pending or confirmed DTCs, noting the current diagnostic codes after the exchange. If the same DTC appears at the cylinder where the ignition coil was moved, it indicates that the ignition coil itself is faulty, necessitating its replacement. If the problem does not follow the coil, move to the next step, which will investigate potential wiring issues further down the circuit. The third step focuses on checking specific wiring and circuitry, starting with the fuse associated with the ignition coil circuit. Once again, turn the ignition switch to the lock 0 position for safety. Next, inspect fuse number A4, which is a 15-amp fuse located in the underhood fuse relay box. This specific fuse is crucial as it serves the circuit powering the ignition coils. After checking the fuse, assess its condition. If the fuse is intact, you can proceed to the next troubleshooting step. However, if the fuse is blown, it suggests a short in the +BIG coil wire between the ignition coil and the number A16 fuse. This will require repair of the short circuit and a replacement of the blown fuse before moving forward. The fourth step consists of checking the ignition coil relay to assess its functional state. Begin by removing the ignition coil relay, designated as Relay A, from the underhood fuse relay box. This relay plays a crucial role in directing power to the ignition coils, making it essential for proper operation. Once removed, test the relay using a multimeter or appropriate testing tool to determine if it is functioning correctly. If the relay tests out as operational, you can proceed to the next troubleshooting step to dive deeper into potential open circuits. However, if the relay is found defective, it will need to be replaced to restore power flow to the ignition coils, after which you'll want to verify the repair. In the fifth troubleshooting step, you will test for potential open wire issues within the ignition coil circuit. Start by reinstalling the ignition coil relay into its original position in the underhood fuse relay box. Following that, disconnect the 3P connector for the affected ignition coil, which allows for testing without circuit interference. With the 3P connector disconnected, turn the ignition switch to the on position to enable voltage measurement. Next, measure the voltage between the specified test points. Test point 1 should be the red wire at connector number 1. and test point 2 is body ground. If you find battery voltage present, the IG1 IG coil wire is confirmed to be functional. If not, this indicates an open circuit in the wire between the ignition coil and relay, which will require repair to ensure continuity. The 6th step focuses on continuity testing of the PG1 lines, which are integral for proper electrical communication within the system. To initiate this step, again, turn the ignition switch to the lock, 0 position. This safety measure ensures that no unintended power is present during testing. Next, check for continuity between test points 1 and 2 using a multimeter. Test point 1 corresponds to the black wire at connector number 2 of the 3P ignition coil connector, while test point 2 connects to body ground. If continuity exists, it indicates that the PG1 wire is functioning correctly, allowing the electrical signal to transmit without interruption. If no continuity is detected, it suggests an open in the PG1 wire, potentially between the ignition coil and ground connection G101, requiring repair before continuing with the troubleshooting process. The 7th troubleshooting step involves examining the IGN pulse lines that are directly connected to the engine control module, ECM. Start by jumping the SCS line with the HDS to ensure all signal paths are verified. After this, disconnect the ECM connector C, which contains terminals specific to the problematic ignition coil. With the ECM powers disconnected, check for continuity between body ground and the appropriate ECM terminal for the specific problem cylinder, as outlined in the diagnostic table. Refer to the diagram for terminal assignments. For example, terminal C25 for DTC P0351, or others for corresponding errors. If continuity is present, you can move forward as the IGN pulse wire is determined to be good. Otherwise, this indicates a fault in the wire, necessitating repair in the circuit. In the 8th and final troubleshooting step, you will again check the continuity of the IGN pulse wires between the 3P connector and the ECM. First, ensure the ignition is set to lock, 0, for safety, as you will also have the ignition coil 3P connector disconnected. Next, measure continuity between the specific ignition coil connector terminal and the corresponding terminal at the ECM connector C based on the diagnostic chart previously provided for each DTC. If continuity is confirmed, it suggests the IGN pulse wires are okay, but you should check if the ECM is updated with the latest software version. If using a scan tool reveals this is not the case, you should consider updating the ECM. In cases where no continuity is found, it indicates a problem with the IGN pulse wire between the ECM and the ignition coil, requiring repairs. To validate the repairs made during the diagnostic process, the final repair verification step is essential. Start by turning the ignition switch to the lock, 0 position, and then proceed to reconnect all connectors that were previously disconnected during testing. Once everything is reconnected, turn the ignition to the on I position to power the electrical systems and prepare for a final check. Use the Honda Diagnostic System, HDS, to reset the ECM, effectively erasing any previously stored DTCs. Following this reset, you should perform a thorough examination of the DTCs once again to ensure no previous codes are active. If DTCs P0351, P0352, P0353, or P0354 reappear, this indicates ongoing issues that necessitate further investigation, particularly focusing on poor connections or substitute ECM if needed. If no DTCs are present, the troubleshooting and repair process can be considered complete. Preventive maintenance is critical to ensuring the longevity and reliability of the ignition system in the Honda Civic. Regular inspections of the ignition coil connections and wiring help identify issues before they escalate into significant problems, enabling timely repairs and continuity of operation. It's also important to stay informed about any ECM software updates. Manufacturers often release updates that correct known issues or improve performance standards. Keeping the ECM updated ensures all control strategies are functioning as intended, minimizing the chances of DTC activations. Moreover, periodically monitoring the performance of ignition coils can be beneficial, as detecting early signs of wear can allow for preemptive replacements, reducing the risk of issues during operation. By implementing these practices, you can maintain optimal vehicle performance and reliability. In conclusion, effectively troubleshooting DTCs P0351, P0352, P0353, and P0354 requires a systematic approach that covers all aspects of the ignition coil circuit. Understanding each component's role, including the ignition coils themselves, the relays, and the ECM, is essential for accurate diagnosis and resolution. Identifying potential causes such as faulty ignition coils, shorted wires, and relay malfunctions allows technicians to zero in on the root of the problem. The importance of preventive maintenance cannot be overstated, as regular inspections and timely updates can significantly reduce the likelihood of DTCs appearing in the first place. By adhering to a structured diagnostic approach and emphasizing ongoing vehicle care, you can enhance the performance and reliability of the Honda Civic and ensure a smooth, trouble-free driving experience. Please like and subscribe to the channel. See you next time!